So this is section 8.2 in pre-algebra, and this section is called the area. And the book says, recall that the area of a flat object is the measure of the amount of surface the object has. So that's kind of a mathematical way of saying that we're looking at finding out how much room this rectangle takes up, or how much grass you could plant in that particular yard. And the area is a two-dimensional, which means it has just two dimensions you're looking at. In this case, area equals length times width. We have two dimensions that we're looking at. If the length is 6 and the width is 5, you do 6 times 5 and you get 30. So again, we're multiplying two numbers, two dimensions. And whenever you're talking about a length of something, that's one dimension. And if you're talking about another length, it's a second dimension. So length times width. A square is a very easy area to find because the square, all the sides are the same. So the area of a square, if this were 3 and this were 3, this is 3 and this is 3. And if you know it's a square, you only need one dimension. And the dimension, or the formula for a square, is just s squared. Take one of the sides and square it. Or if you feel more comfortable, just take the two sides, length times width, and multiply them. You're going to get the same answer. The area of a rectangle is going to be, like I just said previously, length times width, so LW. And the area of a parallelogram is going to be pretty much the same as the area of a rectangle, only they just call it base times height. And one of the important things talking about a parallelogram is notice when we're looking at a rectangle that we have 90-degree angles here. So length times width is the length here times the height or the width of an object that is at a 90-degree angle. Now when we're talking about a parallelogram does not have to be 90 degrees. It can be like this, as long as the top and bottom are parallel and both sides are parallel, it's a parallelogram. But what we've got here is, let's say that this is 6 and this is 12. We do not find the area of a parallelogram by taking 12 times 6, because remember I said in a rectangle, the length and the width, or the base and the height, are always going to be at a right angle or a 90-degree angle. This is not a 90-degree angle here, so this is not the height. The height is actually the distance between here and here at a 90-degree angle. So if I want to get rid of this 6 here, let's not put it on there because that's not really even important. What's important is the height. So let's say that that's 5. So now the area of a parallelogram is 12 times 5, which is going to be 60. It has nothing to do with this length right here. It has everything to do with the perpendicular or the right angle height to the base. Very, very important to remember, because that's the same kind of thing that we're looking at when we're dealing with a triangle, which we'll look at right now. So a triangle is going to, if we have a triangle like this, where this is 3 and this is 6, well, this is the height because it's a 90-degree angle with the base. And the area of a triangle, I'm just going to make area of a triangle, is 1/2 the base times the height, because if you notice, the triangle is 1/2 of a parallelogram, or in this case a rectangle. So we're only looking at this part of the rectangle, so we're going to take half the formula that we normally use. And again, let's say that we have a triangle that looks like this. And if this is 12, and if this is 6, and if this is 8, we can't use either one of these measurements in our area, because the area of a triangle is 1/2 base times height. Well, we know our base is 12, but we don't know the height. The height is always going to be a 90-degree angle to the base. So let's say that that base is 5. So 1/2 base times the height. And again, these numbers here are worthless as far as finding the area of our triangle, unless sometimes it's the case where we need those numbers that I just crossed out in order to find the height, because maybe they don't give you the height. So we'll see if that's necessary. So the next part of this will be the area of a circle. So we talked about the circumference of the circle being 2 pi r. The area of a circle is pi r squared. And a lot of students get those two mixed up. And one of the things that helps me to remember which formula is for the circumference and which formula is for the area is the area is always measured in like square inches, square feet, square yards. It's also 2 dimensions. Remember, we talked about length times width. They're multiplying 2 numbers together, and that 2 keeps occurring. So I remember area by the squared sign here having that 2 up there. It's squared. And that's how I do it. And this is just a 2 times, but this squared here reminds me that my area is in square inches, square feet, square yards, square meters or whatever. That squared symbol right there reminds me that I'm dealing with area. So anyway, they give us example 1, and example 1 is pretty much what we just talked about. We've got our length, or our base, times our height, and they're reminding you that you use the perpendicular height of 2, and just multiply the 5 times 2. And in example 3, they're giving you the exact same thing, dealing with a triangle. So nothing new as far as what they're doing there. 6 times 3 is 18, and then because our area of a triangle is 1/2, base times height, they're going to take that base of 6 times the height is 3, and they're going to take half of it. So you're just going to divide that by 2, so you're going to get 9 for your answer. So remember to divide that by 2 when you're dealing with triangles. So many homework assignments and quizzes and tests I get back where they've forgotten to divide by 2. They just take the 6 by 3 and leave it at there. So example 4 real quick with the area of a circle. They're giving us a radius of a circle, and they're referring to another story problem, but we'll just put the radius that they give us of 14.5, and they're wanting to find the area of that circle. Well, we know that area of a circle is pi r squared, so we're going to take, and I always like to write the formula and then write it with the number before I actually do anything. And so now all we're going to do is take our pi, which is 3.14, and we've got 14.5, and they're asking us to square it. And if we square 14.5, we get 210.25. Multiply those two together, and we get 660.185. But if you look in the story problem, and this is very important, it says find the area of the circle to the nearest whole number. So we're only interested in the left of the decimal. So this here, we can't round that up because this point right here is a 1. So this 0 will not be rounded up to a 1, to 661. It's going to be left just the way it is. So what we're going to do is we're going to scribble out, because my eraser doesn't work, the decimal and get 660. So again, the problem set is pretty same old, same old. I am going to do a couple problems for you just to kind of get you started, but you should be okay.